This video describes abstract classes and interfaces in Java. In the previous section, we talked about inheritance. Abstract classes and interfaces build on the idea of inheritance. They formalize it in a sense. So what is an abstract class? Let's look at that quickly. Okay, an abstract class is a class that is declared with the abstract keyword. It has to contain at least one abstract method, and it cannot be instantiated. And the reason it can't be instantiated is because it has abstract methods in it. Well, you might ask, what is an abstract method? An abstract method is also declared with the abstract keyword. It cannot have a method definition. So usually when you declare a method, you say return type, name of your method, put in your arguments, and then you go ahead and start a curly brace, put all your code to execute, and you end with a curly brace. Those curly braces and all that code for abstract methods are gone. They don't exist. You don't declare a definition when you make a method abstract. And this is why the compiler can't instantiate an abstract object, because there's no definition for the method within it, any abstract method within it, so it doesn't know how to create it. Why do we have abstract methods if they don't do anything? An abstract method is telling the subclass that it has to override this method. It has to define a behavior for this method. It has to define some sort of process. It can be empty, it can be a huge number of calculations, it doesn't matter, but it has to define something. We've been talking about our employee example. And if we go back to our UML diagrams, remember this from our previous week, we have an employee and it has a bunch of fields. It also has a getSalary method and a print method. And now that employee object is extended by part-time employee or specialized by part-time employee. And part-time employee extends the functionality of employee by adding a new field, hours per week, and a different implementation for getSalary. This is all well and good, but now that we have abstract classes, we have sort of a cleaner way to define what this extension interface or extension relationship is. So let's look at a different UML diagram. So in this case, I actually want to call this abstract employee. So in this case, I'm going to create an abstract class called abstract employee, define all these same things here, the same fields, the same methods, except now I'm going to declare my getSalary method within this class as abstract and I'm not going to give it a definition. I'm going to create a new class. We had part-time employee before. I'm going to create a new class called full-time employee. And in here, I'm going to define getSalary the way I would for a full-time employee, the way we had it previously in our last example. And so you can see this makes a very clean structure. It tells the subclasses what needs to be done to give it full functionality. It's telling us that we need to define this getSalary method if we are going to use our abstract employee. And if we look at the Java code for that, we originally had our employee class with our definition of getSalary, which was assuming that we are a full-time employee with this definition. And then we went ahead and made a part-time employee that extended employee and overrode the get salary method. Then we went ahead and used these two classes to create instances of an employee and a part-time employee. Now we're going to do an abstract implementation. So let's go down and look at our abstract class. We declare this class abstract, and then we go ahead and declare our get salary method also abstract. Then when we go to our specializations of it, the part-time employee, we can see that we have an implementation relating to a part-time employee because it includes the hours per week they're working. And then we also have an implementation for the full-time employee that just assumes the hours per week that they're going to have is 40 because they're full-time. And you extend it the same way, and everything works nicely as long as you define all of the abstract methods that are declared in the base class, in the base abstract class. And then we go ahead and we come down to our main, and we now want to use these classes. So first I'm going to start by trying to instantiate an object of type abstract employee. Now, is that going to work from what we just talked about? Well, we can go ahead and try compiling. And we're going to go ahead and get this error. Abstract employee is abstract, cannot be instantiated. And like we talked about before, the reason this happens is in abstract employee, there is an abstract method which has no definition. The compiler doesn't know what to do with that. If you instantiated this object and then called get salary on it, what's the compiler going to do? It has no idea what to do. So we can't do that. So instead, it's going to give us a compile time error. So this is no good. We'll get rid of it. Sorry, mystical unicorn, you're going to have to go away. And we recompile. And I have to close my file. All right, now we recompile. So now we have two objects that we are instantiating from full-time employee and one from part-time employee. Like we saw in our previous example, exactly the same, except now we're making them type abstract employee. And we go ahead and we run this. And we see our first employee printout, their yearly salary calculation based off of a 40-hour work week, and our part-time employee also print out and calculated. This is exactly the same functionality, the same output we'd get if we used our earlier implementation, which just extended one from the other. The only difference here is the structure you're creating to force the subclasses to write the right kind of code, to write the methods and the functionality that you need. And if you don't, the compiler is going to complain about it. So in our lab that we're going to do for abstract classes and interfaces, the first part of the lab, what you're going to need to do is take game object, which several classes are already extending. Our pot object that we just created is extending, our caterpillars, and you're going to make that an abstract class. And in doing that, we are also going to add a implementation of the abstract paint method. You're going to have to make that an abstract method as well within game object. And then we're going to create a paint in our heads-up display so that our heads-up display is truly now a heads-up display and displays to the screen. Okay, so now let's talk about interfaces. Now, interfaces are taking abstract classes to the extreme. If you declare something as an interface, if you declare a class as an interface, all of the methods are going to be abstract. You won't see the abstract keyword used because just by making the class an interface, all of the methods within it are abstract. So you might wonder, what is the use of this? Well, there's a couple different reasons Java has introduced interfaces. In other programming languages, you can do multiple inheritance. So you can actually extend many classes. In Java, you can only extend one. The reason they don't want you to do that is because if you extend from two different classes that both define the same, let's say, run method, the compiler doesn't know which one to choose. It's ambiguous. There's no clear-cut way to figure this out. So Java just says, no, we're not going to do that at all. We're going to have interfaces where you can extend from one class, but you can also extend from as many interfaces as you want. And since the interfaces don't define method bodies, there's no ambiguity about which one to run. There will only be one instance of a method. For an example of an interface, let's take a look at our key listener. Now you should be a little bit familiar with key listener because in the very first branches lab we did, we were actually using key listener. And if you look at the code base, you'll see there's already a bunch of methods defined in our game implementation that implement our interface for key listener. Our game actually implements interface key listener. So we go to look at the method summary here, and this is just straight from the Oracle docs on the key listener interface. You can see all of the methods that it declares. Key pressed, key release, key type. So these are all the methods. Now if we click on the abstract methods that it declares, you'll see it's exactly the same. And that's because what we just talked about, interfaces, everything in them is abstract just by being an interface. And the interfaces describe, they give you an API, they give you a programming interface that your code has to conform to and create the behavior for it. That's so when the graphics framework tells your program that an event happened, your program will react accordingly. So for the second part of your lab, we've already looked at the key listener interface and we've used that. We're actually also going to implement the mouse listener interface. So when a mouse click happens or the mouse moves, you can also take those actions into your game and act on them. And now when your implementation is complete for it defining the mouse listener interface, you'll have a game that gives you some information when the player clicks on a particular game object. So if we click on flower, it's going to say, "You are the flower, get to the pot to be planted as fast as you can," and then tells you what keys to use to move. If it clicks on the pot, it will also give you information. You have to get to the pot to complete your quest. So I hope you enjoyed abstract classes and interfaces, and good luck with the lab.